Starting recording. Oh, not the Starbucks assignment. Do we have any questions, actually, before we get going? Okay, cool. So, last time we were talking about functions. We define a function. We were very careful to distinguish between the difference of defining a function and then calling a function, two very different things. This is the definition. This would be like calling the function. Just name of the function, give it its arguments, you get a result back. That's calling it. It only needs to be defined once, but you can call it however many times you want. And we did take a moment to emphasize that it was, in fact, the same idea as math. We define a function, like f of x equals x times 9/5 plus 32. That's the conversion from Celsius to Fahrenheit. And then we can actually ask the function, well, like, what would the answer be if x was 20? F of 20 is, well, 68, for example. It's the same idea. So if functions are confusing you, just go back to grade 9, and then it's the same as that. It's just math syntax, Python syntax, but the underlying ideas are the exact same. All right. So here's an example of how this would work. Here's the definition of a function, square of sum. If I were to call the function square of sum and I give it the values 2 and 3, Python's going to handle it like this. It's going to say, okay, well, let's go to the function square of sum. Oh, there it is. The variable a, the parameter a, because remember, parameters are just variables, but they're in that parameter list, in the signature line of the function, the definition line. And there's special variables where we can pass information to a function, and then inside the function, they get the information that was passed to it. So they're just like a special variable, but they're just variables. So when I call a function with 2, 3 as the arguments, a becomes 2, b becomes 3. Why? Well, because a was the first one, and 2 is the first one, and b is the second one, and 3 is the second one. That's all. I call that function. A is 2, b is 3. A plus b, well, that's 5. 5 gets stored into c. C times c, well, 5 times 5 is 25. That's like squaring it, right? Multiply it by itself. D becomes 25. Then we return D. Return, where parameters is how we give information to a function. The return is how we get information back from the function. So who wants to be my function right now? I need someone brave. You did last time, so we need someone different. We need someone more brave. You're going to be more brave? Okay, here's the number 2, and here's the number 3. You're the function square of sum. I gave you these two values. You do the calculation, and it's 25. Okay? And you're done with it, right? And here's the funny thing. Me, I'm outside the function. I called the function, but I'm outside the function. I can't look inside him. That's not an option. I can't look inside the function. All I know is that this function exists, and I know what it does. How it does it, I don't know, but I know what it does. So it's the difference between the what and the how. I know what, but not how. But that's okay. You know how. So I've like delegated this work to you, the function. You do the calculation, and now you've done the calculation. You've got the number 25. But as of right now, without a return, I have no way to get that 25 from him. You could say, well, there's a variable d inside there. I don't know that exists. I can't look inside the function. Any variable that is defined and exists inside that function only is defined and exists inside that function. I can't get it. If I were to say, oh, print d, Python would say, what the hell's d? If I put that inside the function, Python would know what d is. But outside the function, it has no idea. So in order to get that information out of the function, we have to return it. So you have to give it back to me with the return. So throw me the number 25. Awesome. Now I have it. So the parameters is how I give information to the function. The return is how I get information from the function. I'm just going to keep going back. See, I'm frozen again. Should I just leave it like this? It's good. It'll be a good thumbnail. There we go. There. All right. Yeah. So any questions about that? Yes, yep, maybe, yeah?
I feel like you're going to answer this question anyways, but like if you use like a print and a function, would that give you the d value that the function returns?
It depends on how I use it. Let's try it right now. So def square of sum a, b, and then c equals a plus b, d equals c times c. By the way, if you're curious, so obviously this will square, because c times c, well, that's the same thing as c squared, right? A lot of people assume that would mean square, which is entirely reasonable to assume, but you'd be wrong. In Python, if you want to square, you do star star. It's functionally equivalent to just doing times c. Then return d. Right? So if I were to say 2, 3, print, let's make sure everything seems fine. It's connecting, yada, yada, yada. See, are we frozen yet? Yep. We'll see how long we last this time. There, 25. So I get the result back. I stored it into the variable result, and then I printed out result. But if I were to try to do something like this, print d, because you'd say, well, d is result, right? I return d and immediately assign it to the variable result, so the value of d and result should be the same. And like, yeah, you're right, but Python's going to say, what the hell is d? Because it only exists inside that function. However, watch this though. This is interesting, right? Because now d is defined outside that function, but the d defined inside the function and the d defined outside the function are, as far as Python's concerned, entirely different. They have the same name, but that's just a coincidence. They are separate. So you have to be careful. If you're thinking, oh no, how am I going to remember this? It actually, as you get going, this is going to become pretty obvious. At this stage, you're new, you're learning it, but this probably won't be something you're going to stumble on a lot. Now, I could put the print inside here. Let's get rid of this one. And that'll work because the print is printing out the d from within the function, and the d is defined inside the function, so we get that d. But I mean, you remember, we usually aren't really going to want to put prints inside our functions. When I say don't put prints inside your functions, I want to be clear about something, however. It's entirely fine to throw, and in fact, I would say it's encouraged to throw prints everywhere in your code to see what your code is doing where. When I hit run and I saw that 25 printed out, oh, okay, the value of d inside that function is 25. When I'm writing that function, I'm debugging, making sure all the values that I think should be what are in fact what they should be. Printing it out is fine. But when I'm done, you get rid of those prints. They're great for writing and debugging and getting a sense of what in fact the values are. But when you're done, we don't really want our prints there. Am I frozen yet? Ah, cool. So any questions about that? Yes?
So is there a way to like, you know how it's like square sum AB, is there a way to like make those inputs so you don't have to manually type 2 and 3?
So we could say like, okay, oh, what did I do wrong? Oh, that's why. 2, 3, 25. So yeah, we could do that, but typically, we don't want to do this. Typically, doing input I/O like this, we don't really do that. A lot of programmers aren't doing that. Inputs, It's fine to do that, but the problem is new programmers are thinking, oh, this is how I want to input information. Usually for this type of stuff, we are just going to hard code the values into the code, like this. That's usually how we're going to do it at this stage. The exception for this class, because, okay, in assignment 1, we're going to read data in from a file. So there is input, but you're not going to enter it in. You're just going to read it from a file. Load it up and then count how many Starbucks are in an area. Number 2 is simulating. There's no input, actually. You just kind of like play around with some of the settings and hit run, and you simulate like an infectious disease scenario. Assignment 3, you will be using input. You play tic-tac-toe. You write a tic-tac-toe game. Great. And then assignment 4, you're just going to read some data from a file again. Really, the only area we're going to be doing the input is assignment 3 and Caddis. In general, we don't really do the inputs like that. So just FYI. But to answer your question, yeah, we could do it. We could. There's nothing stopping us. Other questions? Am I frozen yet? Yep. This is bad today. Holy. I can't keep doing this. There. All right. And then return, well, that's returns a value. Yeah. Cool. And then this is me warning you about Colab being misleading, where it just shows you a value even though it didn't actually print, but it looks like it did. I've warned you about this enough. Now, here we go, real quick. Here's an activity, just so you make sure you're all up to speed on everything we're talking about today. I want you to write a function called Euclidean distance that takes an x1, a y1, an x2, a y2, and I want you to return the Euclidean distance between those 2 points. And if you can't remember, I don't know, when did you learn Euclidean distance? Like grade 10? I don't know. God knows I wouldn't have remembered. So there it is. That's the calculation. Try to get that working in Python. Write yourself a nice function. See if you can get it going good. I'll give you a few minutes for that. Is anyone done? Okay, take your time. I'm not rushing you, just asking. Raise your hand if you're done. Raise your hand if it'll be done in like 20 seconds. Okay, go for it. So the first part of this one was easy. You just take x1 minus x2 squared, y1 minus y2 squared. Right, that's the inside part. But the tricky part is the square root. For those of you that got it working, how did you do the square root? To the power of 1/2. Difference to the power of 1/2, or I guess 0.5 would work, right? Who here did it that way? Cool. Well, that's clever, right? Because we know that to the power of 1, that's the square root. Great. Did anyone do it another way? How'd you do it? You imported math. Yeah. So now we're going to talk about this in a moment. Maybe not. Maybe we won't get to it today. But you know what we write blocks of code and we reuse it a lot. We put it into a function, right? But sometimes you have lots of functions that you might need. And whenever you have lots of functions that you might need, sometimes we put those into like other files. Let me put it this way. There's a lot of functions Python gives you for free, like print, absolute value, type, right? Python gives you these for free. And you don't need to do anything special. But so far, we've used print a bunch. And whether you realize it or not, Python gives you a hell of a lot more functions for free. In fact, there's something called the standard library that's part of every programming language that is basically all of these bells and whistles and tools and functions that you might possibly want to use. They give it to you for free. You don't have to write the function. They know how to do it for you. So they wrote these functions for you, like print. But up until now, how many times have you used the square root? I mean, once, now, right, in our Python code. So it's a function that Python will let you use for free, but you don't get it by default. Print, you didn't need to do anything special. You type in print, it works. If I want to do the square root, there's a function, sqrt, for square root. But if I run this, Python's going to say, what is square root?
You have to
Yeah. So there's a lot of functions, but you don't always need them. So there's no point for Python to load up, because if that function's written somewhere, it needs to get loaded into your computer memory. And you don't want to waste your memory. So it only loads up things that you need. So if you wanted to use the square root function, you might go and you'd say, okay, look, import math. And when you do this, Python goes, oh, okay, so all of those mathematical functions that I've stored in the math library, we're going to load up for them. Because they know they're going to be doing a bunch of math, so now we'll load it. So we went out of our way to say, yes, I want those math functions. And now I have access to math dot square root. And now this will work just fine. Which is a neat little thing. I'll talk a little bit more about this in a moment. But long story short, there's a lot of functions Python gives you for free. Some of them, though, you need to go out of your way to actually import. Yeah, okay. Execution flow, cool. Any other questions about this? Yes?
Could you do that with like 3, 4, 5, 6?
What do you mean?
Like if you make x1 3, y1 4.
Oh, like what's the result?
Yeah, because me and him have two different answers for that. So.
Someone did something weird.
Someone did something wrong, and I want to know
Let's see.
who did it wrong.
Who thinks? Hold on. Who's the difference between?
Okay. So
You wait. Hold on. No, you two. It's between you two.
yeah.
All right. Without looking at their code, put your hand up really high. Who thinks he's right? Come on, commit. All right. Now, who thinks he's right? Oh boy, it's tough. Let's see. Let's see if we're frozen though first. I want to see if, do I have a funny shot? Yeah, well. Oh, no, I'm good. All right. All right. Euclidean distance. What did you say? 3, 4, 5, 6?
Yeah.
3, 4, 5, 6. Okay, hold on. And what does yours say? Yeah, 2.8, whatever. 4. All right, well, let's see. 2.8. Oh, look at that. Some of you bet on the wrong horse, I guess. Yikes. Long story short, you should feel really bad about yourself. That's the story. Do you know what you did wrong? He's looking into it. Okay. Oh, did you do them separate? That'll do it. Try changing it and see if you can get it then. All right, well, execution flow. We already kind of went over this. If I were to hit run on this code, what would happen? Well, Python starts at line 1. And it goes, okay, line 1, oh, well, they defined Celsius, they defined a function. I'm not going to actually execute this function. I'm just going to remember that this function exists, and if they want to use it later, I know where to find it. So line 1, 2, 3, 4, 5, 6, 6. So line 6 is like the first line of code that Python's going to do any number crunching on. And it's a simple line. It just takes the value 24 and throws it into the variable Celsius. We go down to line 7. Okay, Fahrenheit equals, oh, a function call. And I know where that function is. And I've got the value of Celsius. It's 24. So we jump up to line 1. And temp in Celsius becomes 24. We execute line 2, 3, return the value. The value that's returned by this function call gets assigned to Fahrenheit. Because remember, every line of code, the last thing that'll ever happen is the assignment. So we see on the left-hand side, well, that's the variable where I want to put a value. The right-hand side is a function call. So the whole function gets evaluated, the value gets returned, and then it gets assigned. And then we print out the Fahrenheit, line 9, nothing, line 10. Oh, update Celsius, line 11. Oh, a function call. We jump back up to line 1, assign the value 32 to temp in Celsius, run line 2, 3, 4. We return, store the value in Fahrenheit, print out the result. So like our execution, it's kind of like jumping all over the place, but it's it's not like jumping all over place in some stochastic random way. It's very predictable. We know exactly how it goes, but it's just doing exactly what you tell it to. One line at a time. It's just that those lines might look like they're going out of order, but they kind of aren't going out of order in the sense that I would know that the lines going would be 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 7, 8, 9, 10, 11, 1, 2, 3, 4, 11, 12. Yeah? Because when I make that function call on line 7, it's like I'm almost like inserting the lines 1 through 4 onto that line. Those lines have to get run before it carries on from line 7 and so on. One thing to watch out for, and this is a very common thing that early new programmers make, and I'll make this mistake every once in a while. So let's say I've got this. Okay, great, cool. But let's say I accidentally forget to do that. And I hit run and I see this. Have any of you seen something similar-ish to this yet? Yeah. What you have done by accident, and not a lot of programming languages actually let you do what Python's doing here. What you've actually done is, on line 7, we never actually called the function, because we never actually gave like a value as an argument. I never gave that function a number to calculate. What we actually did, like what I mean is there's no parentheses with a value in between. What I've done is I've taken that function and I've assigned the whole function to that variable. And then I printed out the contents of that variable, and well, that's how the function is represented as far as the computer's concerned. Really what it is just the name of the function, and then it's got this like hash code memory address thing. That's like where you can find it on your computer or on Google's computers. And a funny thing here is I can actually say like 2055, and now this will work, which is weird, but more on this another time. So if you ever see something like this, and you're like, well, that's just the name of the function. What the? It's because you didn't call the function. Oops. You accidentally just like assigned the function something else. Yeah?
What you did earlier, does that mean like if you assign Fahrenheit to be the function?
Yeah, to the whole function. So now in this particular situations, I actually have two different names for the exact same function. One is, well, what we defined it as, the Celsius to Fahrenheit. And the other one was called Fahrenheit, which is kind of a bad name for the function, but yeah. So in this case, we would actually call that an alias. It's the same function, but we actually have two different names for that function. Not a lot of programming languages let you do stuff like this. It's kind of like a neat thing Python lets you do, which is very powerful. There's some advantages to it, but it messes up new programmers a lot. It messes up experienced programmers who aren't used to Python a lot as well. Okay, this is, okay, abstraction. So, like, we won't do this activity for the sake of time, but I would like to, like, we could still do this as like a thought experiment. Like, and we did this already like 2 weeks ago. If I told you to boil spaghetti, right? Like if I said, how do you make spaghetti? Or penne, or whatever the hell your favorite pasta is. If I were to tell a human on how to make spaghetti, I would say, okay, put some water in a pot, add some salt, wait till it boils, throw the spaghetti in, wait, 8, 10 minutes, whatever, and then it's done, right? That's how a human would operate, because a human knows how to operate in their environment. They have a sense of how cooking works, right? That's how you would make pasta. Pretty simple. But because if I was explaining this to another human, humans operate at a fairly high level of abstraction. Now, chances are before this class, we've heard the word abstraction before, but in this particular class, we're using that word a lot. And it's because, well, it's an important concept. I can explain to you how to make spaghetti, or penne, or whatever the hell you like, at a fairly high level of abstraction. I can tell you how to drive to superstore from here at a fairly high level of abstraction. I don't need to start explaining to you, okay, lift your right leg. Put your right leg down further in front of itself. Lift your left leg. That is at a much lower level of abstraction. And thank God, I don't need to explain things to you at that low level of abstraction. In fact, we could play this game forever, where we could say like, okay, contract muscles, right? Or, oh, okay, fire neurons to contract muscles. Oh, start thinking about or ion pumps for the differential, for the synapses to start firing in your neurons. And oh, now we can actually start talking about the chemical properties of salt and how that... I could operate at that level of abstraction. That would piss you off, but I would give you a pretty accurate description on how to get to Walmart, but it would take forever for me to describe it to you. That is at a very low level of abstraction. We like to work at a fairly high level of abstraction because it's so much easier to communicate ideas, because we have like a shared understanding of a lot. Functions really help us facilitate abstraction. If I say boil water, think of all of the steps. Imagine, like this might seem silly, but seriously, imagine there exists a function in your head on how to boil water. When I say boil water, you know all of the steps involved on how to boil water. Get a pot, go to the tap, fill it up, put it on the stove, turn on the stove, right? There's a lot of steps involved. But I was able to tell you just boil water. And you were able to break that down into the steps because you know. So when I say boil water, that's an instruction I'm giving you, but it's a high-level abstraction. Pardon me. It's a fairly high level of abstraction because you can break down that problem into its that instruction into its sub-instructions. But if I had to explain all of those sub-instructions to you, and each one of those, it's sub-instructions and so on and so on and so on, that's crazy. So this function idea really helps facilitate abstraction, which is a very important idea. And it also really helps us to differentiate between the what and the how, right? If I tell you to boil water, and you to boil water, and you to boil water, I'm telling you what to do, but I'm not telling you how to do it. You know how to boil water in your kitchen, but I don't know how to do it in your kitchen because I don't know where you keep the pots. Does your tap not work? Do you have to go to the other room? I don't know, right? Like it all really depends on a lot. So it differentiates between the what and the how, which is also an important idea. And this is an idea that if you continue learning computer science, this is an idea that's going to be hit hard, especially next semester. We really hit that idea because it's an important distinction. It's funny because a lot of these ideas, if you say, I've never done programming before, okay, fine, you've never done programming before, but you've been doing computation your whole life in your head. You know how to do it. And you instinctually know the difference between the what and the how. But sometimes it's funny because you've never really thought about it before. Raise your hand if you have ever, in the history of your life, sorted anything ever. Put your hands up. Of course you have, right? You've sorted things before. I don't care if you were sorting them based on color, height, alphabetically, whatever. It doesn't matter. You've all sorted something before. And you knew how to sort things. You just did it, right? But how many of you thought to yourself, I'm sorting these things, and these are the individual instructions I'm going to do. First, I'm going to pick up this page and check their names. And if that letter comes before... You probably didn't really think about it like that. You just sorted things. But you did sort something. Meaning you knew how to sort something. You just never really thought about it before. So near the end of the semester, we're going to start talking about sorting algorithms a little bit. It's a little bit outside the scope of this course, but we'll talk a little bit about it. You've all done it. You know how it works. But in spite of having a full semester of programming under your belt, by the time we get there and I say, now explain to me how you sort things, you're probably going to suck at explaining it despite knowing how to do it. It's a weird thing that you know how to do something, but you can't even explain how you're doing it. Because you're so good at computation and solving these problems, you don't even think about it. But as programmers, it's important to think about it because that's what we do. We break these problems into their steps that we execute to solve problems all the time. So whenever someone tells me at the end of the semester, I guess I'm just not good at it, bullshit. You made it here today, you can do computation. If you've made it this far in life, you can do this. The hard part is just practicing breaking these things down and thinking about it. That's not trivial. I'm not saying that you should be able to do that easily. I'm saying that you all, at the end of the day, whether you like it or not, are pretty good at this stuff. You just probably haven't really thought about it before. Remember, programmers are stupid. We can't do anything more complex than one stupid little simple step at a time. So our goal is to break things down into the stupid little steps that we can solve. And the next thing you know, we put that all together and we've got a solution to the problem. Great. Any questions, comments about that little rant? See if I'm frozen yet. Yep, I like that one. We'll do this one last time today. Okay, making use of abstraction. We've been doing that. That's like the prints. Creating abstraction. Well, we wrote a function to calculate, to convert Celsius to Fahrenheit. At this stage, if you've got that function in your pocket, Celsius to Fahrenheit, do you need to remember how to convert Celsius to Fahrenheit? No. You just need to know, I got a function that does that. Obviously, it wouldn't be a bad thing to know how to convert Celsius to Fahrenheit, but you've got a function to do that. Do you need to know how the print function works? No. Thank God I don't need to know. I don't know, but I can use it, which is great. We write functions to calculate the square of the sum. Anytime you need the square of the sum now, call that function. No need to actually calculate it yourself. It might feel at this stage these are contrived examples, because they kind of are. They're simple, right? Calculate the square of the sum. Okay, fine. You add them together and then square it. What's so hard about that? Fine, that was a simple function. But as we go, like who here's looked at assignment 1? Any of those functions, yeah, they get a little bit more complex. They're not crazy, but they are more complex. Yeah, I wouldn't want to think of like calculate the density of Starbucks in terms of all of the steps. Thank God I have a function that can calculate the density of Starbucks. By the way, here's my biggest, raise your hand if you're a first year. Okay. Here's my biggest advice for a computer science class, how to do a computer science class assignments. This is right now I'm giving you brilliant wisdom. I don't know how well this translates to history or anything else. I can tell you how it works. I can tell you this works really well for computer science. I always give you like about 2 weeks to do an assignment. Based on where we are now, I'm probably going to set the deadline for next Monday. I'll think about it more and update it, and I'll send an email out just to confirm that. But here's how I would always do it. By like my 3rd year, I had this figured out, and this worked for me every time. And it might not work perfectly for first years, especially at this stage, like in programming 161, first assignment. But maybe by assignment 2 and 3, this will work really well. Because, well, let me explain. I get the assignment, and it's released, and I know it's due in 2 weeks. Immediately, as fast as I can, I'm going to read through the assignment. Not blitz through. Like, I'm going to take my time, read through it, and I'm going to have an expectation that I'm not going to write a single line of code for at least a week. Do not sit down and be like, okay, I read it, I'm going to start coding. I recommend against that. Now, I don't recommend against that if you read the assignment the day it's due and you need to start, yeah, okay. But I recommend against waiting that long. Read it as soon as you can with the expectation that you're not going to write a single line of code yet. Because you need to give yourself enough time to think about the problem. On these assignments, you're new at programming. Writing the code is the last thing you do. People think writing the code is the assignment. Nope, not at all. The assignment is reading the problem, understanding the problem. When people come to office hours saying, but I don't understand the problem, I go, okay, I'll help you understand the problem, but you have to understand that understanding the problem, the task of reading a problem and understanding what the hell it's asking you, is part of the assignment. So once you understand the problem, you need to spend time to think about what's the solution. Which is, the solution and the code are independent. And then once you have a solution, you can start writing the code. Don't write the code before you know what the hell you're supposed to do, or you even have an idea what the solution is. So make sure you give yourself time to understand it before anything else.